Imagine for a second that everything you know about reality is only half the story, that every choice you've ever made, every path you didn't take, and every version of yourself you've ever imagined actually exists right now, just out of reach, in a dimension mirror image to our own. For decades, the idea of a parallel universe was nothing more than a convenient plot device for comic books and high-budget sci-fi movies. But a series of anomaly detections in the frozen wastes of Antarctica and new data from the most sensitive particle detectors on Earth have just sent shockwaves through the physics community. Researchers have discovered high-energy particles that shouldn't exist according to our current laws of physics, particles that seem to be moving backward in time and emerging from the Earth itself. The leading explanation? We may have finally found the first physical evidence of a mirror or parallel universe that was created alongside ours during the Big Bang. This isn't just a wild theory anymore. We are talking about hard data that challenges the very foundation of the standard model of physics. Today, we are breaking down the shocking discovery that suggests our universe has a twin, why the world's top physicists are scrambling to rewrite the textbooks, and what it actually means for the fabric of reality as we know it. To understand why scientists are so rattled, we have to talk about how this all started. It didn't happen in a high-tech lab in Geneva or a telescope in Hawaii. It happened in one of the most desolate places on the planet, Antarctica. A team of researchers was operating the Antarctic Impulsive Transient Antenna, or ANITA. Now, ANITA is basically a giant balloon carrying a sophisticated array of radio antennas high into the stratosphere. Its job is to detect ultra-high energy cosmic rays and neutrinos, ghostly subatomic particles that travel through space at nearly the speed of light. Normally, these neutrinos come screaming down from deep space, strike the Antarctic ice, and produce a faint radio signal that ANITA picks up. But during several flights, ANITA detected something that seemed impossible. It picked up signals of high-energy neutrinos coming from the Earth, moving upward. In the world of physics, this is like seeing a glass of water fall off a table and splash onto the ceiling. High-energy neutrinos are supposed to be stopped by the solid mass of the Earth. They are so energetic that they should collide with atoms as they pass through our planet, meaning we should never see them coming out of the ground. When the data first came in, the team thought it was an error. They checked the instruments, they checked the calibration, and they checked the math. The anomalies kept happening. These upward-going events suggested that particles were passing through the entire planet without a single collision. According to our current understanding of physics, this is forbidden. If the particle is that energetic, it must hit something. The only way it could survive the trip through the Earth is if it wasn't following our rules of physics at all. This is where things get truly mind-bending. A group of theoretical physicists at the Perimeter Institute and other top universities started looking at this data and asked a terrifying question. What if these particles aren't moving upward through the Earth, but are actually moving backward in time? In the standard Big Bang model, we assume that the universe exploded into existence and expanded forward in a single direction. But these researchers proposed a new model called the CPT symmetric universe. In this version of reality, the Big Bang didn't just create our universe. It created a pair of universes. Ours, which is dominated by matter and moves forward in time, and a mirror universe, dominated by antimatter, that moves backward in time from our perspective. If this parallel universe exists, it would solve some of the biggest headaches in science. For example, why is there so much more matter than antimatter in our world? In our universe, antimatter is incredibly rare. But if there's a twin universe where the balance is flipped, the total accounting of the cosmos remains perfect. It would also explain the mystery of dark matter. Some of the particles we see as dark matter, the invisible stuff that makes up most of the mass of the galaxy, might actually be regular particles from the mirror universe that we can only feel through their gravitational pull. Those weird neutrinos detected in Antarctica? They might be sterile neutrinos, particles that originate in the mirror universe and can pass through our planet like ghosts because they only interact with our reality through gravity and these rare, high-energy breakthroughs. The shock in the physics community comes from the fact that this theory is actually testable. Usually when people talk about parallel dimensions, it's all math and no proof. But the ANITA detections gave us a physical signal to investigate. Since that discovery, other experiments have started looking for similar clues. The IceCube Neutrino Observatory, which is a massive detector buried a mile deep in the Antarctic ice, has been reviewing its data to see if it missed these forbidden particles. While they haven't found a definitive match for the exact energy levels Anita saw, they have found other strange gaps in the data that suggest our current standard model of physics is incomplete. Many physicists were initially very skeptical. After all, extraordinary claims require extraordinary evidence. Some argued that the Anita signals could just be reflections of cosmic rays off the ice or some weird geological property of the Antarctic rock. But as more researchers run the simulations, the mirror universe hypothesis keeps gaining ground because it is the most elegant explanation for the strange symmetry we see in the cosmos. It's based on a fundamental principle called CPT symmetry: charge, parity, and time. Physics tells us that if you flip the charge of every particle, mirror its position, and reverse the flow of time, the laws of physics should still work exactly the same way. The mirror universe theory takes this principle and applies it to the entire Big Bang. So what would this parallel universe look like? It's not necessarily a world where you have a twin who wears a different colored shirt. It's a world where the fundamental arrow of time points the other way. From our perspective, that universe is shrinking toward the Big Bang as we expand away from it. But if you were inside that universe, everything would feel normal to you. You would see the stars expanding. You would experience life moving from birth to maturity, and you would think that our universe is the one moving backward. It's like two people standing back to back and walking away from each other. Both think they are moving forward, while the other is moving away into the distance. The existence of a mirror universe would also change how we think about the beginning of everything. Instead of the Big Bang being a point where time magically started, it becomes a point of symmetry. It's more like a mirror placed in the middle of a room. On one side, you have the world we know. On the other, you have the reflection. This model removes the need for inflation, a period of extremely rapid expansion that scientists previously had to invent to make their Big Bang math work. By introducing the parallel universe, the math becomes much simpler and more stable. In science, the simpler explanation is often the one closest to the truth. But wait, it gets even more interesting. If there is a parallel universe connected to ours through this point of symmetry, could we ever communicate with it? Some researchers suggest that gravity is the only force that is strong enough to bridge the gap between dimensions. This is why we can't see the parallel universe with a telescope, but we might be able to feel its effects through gravitational waves. When massive objects like black holes collide in our universe, they send ripples through the fabric of space-time. If there are similar massive events happening in the mirror universe, those ripples might be bleeding through into our reality. We might be detecting shadow gravitational waves that have no visible source in our sky. The shockwaves in the physics community are also driven by a sense of urgency. For the past 50 years, we have been stuck. We have the standard model for small things like atoms and general relativity for big things like galaxies, but the two don't talk to each other. We are missing a theory of everything. The discovery of these anomalous particles in Antarctica might be the first crack in the wall that allows us to build a bridge between these two worlds. It suggests that there are hidden sectors of physics that we've been ignoring because they didn't fit into our forward-moving, matter-only view of the world. There is also the question of the cold spot. For years, astronomers have been puzzled by a massive, unusually cold region in the cosmic microwave background, the afterglow of the Big Bang. This cold spot shouldn't be there according to standard models of the early universe. Some controversial theories suggest that this spot is actually a bruise on our universe, caused by a collision with another parallel universe early in our history. While this is a different theory from the mirror universe found in the Antarctic data, it points in the same direction. Our universe is not alone. It is part of a much larger, much more complex structure that we are only just beginning to map. If you are listening to this and feeling a bit overwhelmed, don't worry, most scientists feel the same way. The idea that time can move backward, or that there is a vast antimatter world just on the other side of a quantum mirror, is enough to make anyone's head spin. But this is exactly how science progresses. We detect an anomaly that doesn't fit the rules, we try to find a reason for it, and eventually, we realize the rules were too small. Just as we once realized the Earth wasn't the center of the solar system, and then that our galaxy was just one of billions, we are now realizing that our entire universe might be just one half of a larger whole. Technological advancements are now being tailored specifically to hunt for more evidence of this parallel reality. New balloons are being designed for Antarctica with even more sensitive antennas, and plans are being made to put similar detectors in space, away from any potential interference from the Earth. We are also seeing a new interest in precision gravity experiments. If we can find a tiny, unexplained deviation in how gravity behaves at very small scales, it could be the proof that another dimension is pulling on our matter. The shock of this discovery also has a practical side. If we can confirm that mirror particles exist, it opens up a whole new field of technology. We are already using antimatter in medical imaging, like PET scans. Imagine what we could do if we understood the physics of a mirror sector. It could lead to new ways of storing energy, new forms of propulsion, or even a way to detect things in our own universe that were previously invisible. We are looking at the possibility of a dark sector of technology that uses the hidden laws of the parallel universe to solve the problems of our own. But let's think about the philosophical side for a moment. If there is a universe where time moves backward, does that mean the past is still happening there? When we look back at the Big Bang, we are looking at the start of our time. But from the mirror universe's perspective, that same moment is their future. This suggests that time is not a moving river, but a massive static landscape that exists all at once. Every moment we have lived and every moment we will live is already mapped out in the geometry of the two universes. It changes the concept of fate and free will into something much more geometric and structural. The physics community is currently divided into two camps. There are the traditionalists, who are working hard to find a way to explain the Anita and IceCube data using standard, forward-moving physics. They are looking for ways that regular neutrinos could behave strangely or for hidden properties of the Antarctic ice that could create false signals. Then there are the pioneers, who believe that the anomalies are too consistent and too strange to be anything other than new physics. They argue that we've been trying to force the universe into a matter-only box for too long, and that it's time to embrace the symmetry. The coming decade is going to be one of the most exciting eras in the history of science. As the James Webb Space Telescope looks deeper into the early universe, and our particle detectors become more precise, we are going to get more pieces of this puzzle. If the cold spot in the CMB and the upward-moving particles in Antarctica are connected, we are looking at a total revolution in our understanding of reality. We will have to update the maps of the cosmos to include a second, invisible half. There is also a fascinating theory involving quantum entanglement on a universal scale. Some researchers believe that our universe and the mirror universe are entangled, meaning what happens in one affects the other instantly, regardless of distance. This could explain why the laws of physics are so perfectly tuned for life here. If the two universes are balancing each other out, it might be that our universe has the specific properties it does because the mirror universe has the opposite. We might be two sides of a cosmic scale, forever locked in a delicate dance of balance. The Anita experiment was never intended to find a parallel universe. It was a relatively small-scale project designed to study cosmic rays. But that's often how the biggest discoveries happen. We look for one thing and find something else entirely that we weren't even prepared for. It reminds us that no matter how much we think we've figured out, the universe is always hiding a surprise. The fact that this surprise suggests a twin reality is both terrifying and beautiful. Imagine a scientist in the mirror universe, thousands of millions of years in our past, launching their own version of a balloon over their own version of Antarctica. From their perspective, they might be detecting particles from our universe moving backward into their ground. They might be just as shocked and confused as we are. We might have been exchanging signals for eons without ever realizing it. It's a silent, cosmic conversation between two worlds that can never actually touch, but are inextricably linked. As we move forward, the search for dark matter is going to be the front line of this battle. If we find that dark matter is actually mirror matter, atoms and molecules from the parallel universe, it would be the discovery of the millennium. It would mean that most of the stuff in the universe isn't some weird, unknown substance, but just regular matter that happens to be on the other side of the time mirror. We could finally see the dark matter by looking for its mirror image signatures. The shock in the physics community isn't a bad thing. It's a sign of growth. It means we are on the edge of something so big that it scares us. It means we are finally asking the right questions. We are moving away from the standard answers and looking into the dark, into the mirror, and into the past to find the truth. The parallel universe theory isn't just about an Antarctic balloon or a few weird particles. It's about the courage to follow the data wherever it leads, even if it leads us to a world that defies everything we thought we knew. So the next time you look at your reflection in a mirror, think about the universe. Think about the possibility that somewhere out there, a mirror image of our entire reality is playing out in reverse. It makes our world feel a little less lonely and a little more mysterious. The data is in, the researchers are working, and the community is in shock. The veil between dimensions is thinning, and we are finally getting our first glimpse of what lies on the other side. The journey to understand this mirror universe is just beginning. Every new data point from IceCube, every new flight of Anita, and every new observation from our telescopes is a step closer to the truth. We are like children looking through a keyhole into a much larger house. We can only see a tiny sliver of the room, but what we see is enough to tell us that the house is much bigger than we ever imagined. In the coming years, we might find that this parallel universe isn't just a twin, but part of a multiverse, made of many different realities, each with its own laws and its own flow of time. For now, the mirror universe stands as the most compelling and evidence-backed theory we have. It explains the anomalies, it respects the math, and it adds a sense of poetic symmetry to the beginning of the world. The idea of a twin universe moving backward in time might sound like science fiction, but so did black holes, the Big Bang itself, and the idea that time slows down the faster you move. All of those were once considered impossible by the physicists of their time. The shock we feel today is the same shock researchers felt when Einstein proposed relativity, or when quantum mechanics was first discovered. It is the feeling of the impossible becoming the proven. Physics isn't just about formulas on a chalkboard. It's about a deep, fundamental drive to understand who we are and where we came from. The discovery of a potential parallel universe is a giant leap in that quest. It takes us closer to the heart of the big mystery and shows us that life, reality, and time are much more flexible and resilient than we ever gave them credit for. As the experiments continue in the frozen deserts of Antarctica and the deep space telescopes of our orbit, we should keep an open mind. The universe is telling us something. It's telling us that the rules are about to change. It's telling us that we are part of something vast, ancient, and perfectly balanced. The mirror is there. We just have to be brave enough to look into it. The story of the parallel universe discovery is a reminder that we are living in a golden age of science. We have the tools to see the invisible and the math to understand the impossible. We are no longer limited by what we can see with our eyes. We are building the bridges to the other side, particle by particle, antenna by antenna. And what we find there might just be the greatest story ever told. So stay curious and keep an eye on the headlines. The next big breakthrough could happen any day. The physics community might be in shock now, but soon that shock will turn into a new understanding, a new set of textbooks, and a new way of looking at the stars. The mirror universe is calling to us from across the Big Bang, and we are finally starting to listen. This isn't just about upward-moving particles or weird neutrino detections. It's about a fundamental shift in the human perspective. Just as we realized the Earth revolves around the Sun, we are now realizing that our entire reality is just one part of a cosmic duality. This parallel universe is a testament to the beauty and complexity of the universe, and our discovery of it is a testament to the power of human curiosity. We have traveled far to find this evidence, and yet we have so much further to go. The mirror universe is there, waiting for us to unlock its final secrets. And when we do, nothing will ever be the same again. The shock is just the beginning. The real adventure starts once we cross the threshold of the mirror and start to map the other side. We are the explorers of the 21st century, and our frontier isn't just a new continent or a new planet. It's a new universe. The data is waiting, the engines of science are turning, and the mirror is reflecting a future that is more incredible than anything we ever imagined. Stay tuned, because the story of the parallel universe is far from over. In fact, it's just getting started.